Welcome back. Today we're continuing our conversation on adding and subtracting radical expressions, or as the name calls it, binomial radical expressions. So, yesterday we started foiling at the end of our lesson. However, I want to recall and help you remember some unique foiling situations. So, if I have it written squared, like I have those first two examples, what I want you to remember is what that actually means is you have it written out twice. Okay, so I want you to write it as such so you remember that this is a foiling problem. All right, it is critical you remember to write it out that way because now you can get 4 plus 2 square roots of 3 plus another 2 square roots of 3 plus square root of 9, which is just the number 3. So ultimately, 4 plus 3 is now 7. Then 2 plus 2 is 4. Okay, so this really doesn't take much more effort than what I was having to do yesterday. I just need you to for sure remember to write both of them out separately, and then you can see the foiling process happening. Just like this one, I'm going to write out twice because it's squared. And now you can use the foiling process. So here I get 9 minus 3 square roots of 10 minus 3 square roots of 10. Negative times a negative is positive, and square root of 100 is just 10. 9 plus 10 gives me 19. Negative 3 minus another 3 is a negative 6 square roots of 10. So, again, just recall the key to being successful with ones that look like those is simply making sure that you write it out twice. Okay, if something is squared, it means you're multiplying it by itself. Now, what about these? Now, for these, something really fun happens. Okay, so when I try to FOIL these out, I get 16 negative 4 square roots of 7 plus 4 square roots of 7. Square root of 49 is a 7. Now, this should look familiar to you. You saw this back when we did imaginary numbers too. Whenever you have the same thing, just differing by the sign, those insides cancel. 4 square roots of 7 minus 4 square roots of 7 simply cancel off, and that's going to leave you 9. So remember we had a special word for that, okay? And I'm going to get to that special word in just a moment. But when you have this situation where you have exactly the same thing, just differing by a sign, remember you're always going to be getting a whole number because those insides are always going to cancel. So I get 4. 2 square roots of 6 minus 2 square roots of 6. That is going to cancel off, okay? And then I'm just going to have minus square root of 36, which is just 6. And that's going to leave me negative square root of 2. So these ones should be actually particularly easy and simple for you, okay? You just have to remember that if you have the same thing, just differing by a sign, remember that you can just cancel off those inside terms, and all you have is the outside, which will simplify to a nice number. And the special name that I was referencing is conjugates. Conjugates are expressions like square root of a plus square root of b or square root of a minus square root of b that differ only in the signs of the second terms. When a and b are rational numbers, the product of two radical conjugates is a rational number, okay? It's going to give you a nice number. So please do jot that down at the bottom, add that to your notes for me before we move on to the next page, because this conjugate stuff is actually important for division problems. And you've seen conjugates again, dealing with imaginary numbers back in chapter 4. So we are actually going to manage these exactly the same way. Okay? I'm going to use the conjugate. I'm going to multiply by the conjugate. So then I'll get nice, easy solutions. So here, if I look at this, I want the conjugate of this. Well, that means I use that idea of using the opposite sign. Okay, that is the conjugate. So on top, I can just distribute whatever's there, okay? The top is easy. The bottom, I'm going to FOIL out now. So on the bottom, now remember the following process actually isn't that tricky because I get 4. Then the insides cancel. 2 squared root of 3 minus 2 squared root of 3 is gone. You don't even have to worry about it. And then here, minus the square root of 9. The square root of 9 is 3. So remember, when you're using the conjugate, the goal is you're always going to get a nice number in the denominator. In this case, that denominator is 1, and dividing by 1 doesn't actually do anything, so it just reduces to that. But again, just to reiterate, the goal of rationalizing the denominator, of using the conjugate, is you're trying to get the radical out of the denominator. You're trying to get the radical out of the bottom of the fraction. So let's do this a couple more times just to make sure you're feeling comfortable. So the conjugate, you flip the sign of that middle term, and now you use your skills of simplifying and reducing. On top, that just distributes. On the bottom, you're always going to get a foiling process, but remember, it's always going to turn out nicely. So that's going to turn into a 25. 5 square roots of 2 minus 5 square roots of 2, that inner piece always cancels out, minus square root of 4, which is just a 2. So you look at that and you see, well, I've completed my goal. There's no more radical in the denominator, so that's going to mean that I am done. Okay, finished with that problem. Once the denominator has no more radicals, you've done your job. And for this one, again, let's flip the inner sign to get my conjugate. And now, distribute on top. Then on the bottom, square root of 49, which is just 7. Then 2 square roots of 7 minus 2 square roots of 7. The insides cancel off. Minus 4. So you get negative square root of 7 plus 2 all over 3. Or if you wanted to clean that up a little bit, if you wanted to write it like this, that is another perfectly acceptable answer. So again, I don't think this is particularly difficult because this is exactly what you saw back in chapter 4. You've done this skill before. Now you're just having to apply it to radicals instead of complex numbers. All right, so Again, thank you so much for joining me for this. Make sure you take a moment, fill in that summary, and a really good idea maybe making those connections. Describe how you can use your chapter 4 knowledge and apply it to here. That'd be a fantastic thing to talk about. Just have something for your summary for me and then come back ready to continue your practice work in class.